Hi everyone, welcome to OracleDBA.in. In the current video, I would demonstrate about I/O consumption and how to recognize I/O contention on the different devices or the hard disk or the or different LUNs being associated with the database. To do that, what I have done in the test case is I have plugged in a hard disk of mine on my own system, and I would simulate a test case wherein I would create one of the data file at my normal hard disk and one of the data file I would create on one of my external hard disk, and then I would demonstrate how you could recognize the different I/O throughput between the current writing or reading of the database. Now let me demonstrate it to you. Over here in my system database, in which I have some of the data file created on C drive. As you could see over here, I don't have any of the other drive apart from C and D, and I'm just plugging in my external hard drive on the system. This new hard disk will be mapped to another drive over here. Just waiting for it to be recognized by the system. Now here you could see the new drive is being mapped as H drive. It has enough amount of space. The next thing that I would do is I would create two table space within Oracle. One table space will be mapped to C drive, that is my local hard disk, and the second table space would be mapped to H drive, which is my external hard disk. And my demonstration would be that I would be creating two tables which is of same size across these two table spaces. That means the data of one table will belong to a hard disk of one of my local hard disk, and the data of second table will map to another hard disk. And once I'm done with this, I would be doing a read across both the table at the same time, and I would try to simulate a physical read, and then I would try to demonstrate you that how you can read out the behavior of I/O on the system. Now let's start with the demonstration. This is my first table space. This is of 10 MB. The first data file is created as C data01.dbf, that is my local hard disk. The second data file that I have created is on TB2 table space, and that belongs to H drive, which is my external hard disk. Although I am assuming that my external hard disk is slower as compared to my local hard disk, because it has to be demonstrated by Oracle, in the entire example I would show you how you can diagnose and detect about the I/O responses from Oracle database. Now let's create two tables which is of same size across these two table spaces. This is my table 1, in which I have created on TB1, that is table space 1, and the second table which I have created on table space 2. Now if you look at the size of the tables, at the database level, the size of the tables are same, both are of 8 MB. Now in order to simulate a reading to these tables, I would run a procedure which will execute a select statement against these two tables at a periodic interval. Now everyone knows who have worked with Oracle database that once a table is read into the memory, the table resides in the buffer cache. So next time if the same table is accessed, rather than making a physical read to the disk, the table would be available from the buffer cache itself. But since in our case we are simulating an I/O related I/O contention or the I/O measurement, I would need to flush out the buffer cache at every interval of my iteration. Here is what I have done in the procedure. I have created two cursors. One is for test 1, another is for test 2. At every loop I am running a alter system flush buffer cache. That means buffer cache will be flushed off after a query is being executed, so that next time also it does a physical read rather than doing a logical read. So let me execute this procedure. The idea of this procedure is to run a read against the table. The procedure name is physical_read. Now as soon as I would execute this procedure, I would take up another session to monitor the IO response at that time. Now what I would do is, instead of running the procedure now, I would take a shutdown and startup of the database to have a fresh measurement. Although it's not mandatory, since I'm demonstrating it from the beginning, I would take a shutdown and startup of the database. Here I have one session in which I would be running up the procedure, and the second session where I would be monitoring the IO contentions or the uses of disk at the database level. Now this is the procedure which I would execute. Now I have started the procedure over here. Now let's go to this location where I am connected through a sys user. And thus I need to monitor. So this is the query by which you monitor. So even one of my friend Biju has asked a question about how to find out IO response from the database level by a storage admin. If a storage admin has an access to say sysdb, and they want to find out which partition is behaving what for the database, this is how you could find out. You could run this query. I would be pasting out this query on the article as well. You could run this query, and this let me change the formatting. Now over here you could see I have two data file of my interest. The first one is H, second is C. If you see over here, to do 878 block of reads, it only required 731 time. For the same amount of work, for 857 block of read, it required 835 of read time. Now if you take the ratio of these two, you would see that 0.97 is the read ratio when you work with H drive, and similarly when you work with C drive, it is faster. If you keep on doing the same, you would see the difference will keep on increasing. This clearly shows that H drive is slower as compared to C drive. So when you're working on the production environment with SAN devices or NAS devices in place, you could figure out by doing a sub STR against your devices in use. And then once you have the devices available, you can figure out that for a read to a particular device, how much time it takes for a same block of read across all the devices in the database. There's another possibility that the same device or the same disk in which your LUNs are allocated is being used for some other process, or for some other software may be running onto that, or because there is a CPU contention, you have a cascading impact running on. So that's also one of the case, but from the database level, this indicates that there is an IO contention. By ratio, you could recognize that there is a ratio discrepancies across these two disks. And since because I know that I am running the same amount of load across these two tables, which belongs to these two table spaces, so the amount of read is almost similar. But to do this much amount of read onto table space which belongs to my external hard disk, it takes a lot of time, nearly double the time you could see over here. And when you read it from the local disk, it takes half of the time. So this is all about diagnosing IO contention at the dictionary level.